was going to talk to you a little bit about what we do at the Health and Safety Laboratory before talking a little bit about disinfection and then introducing Surfacide. So the Health and Safety Laboratory is based in Buxton. We're the laboratory of the Health and Safety Executive. We have approximately just over 400 people that work for us. And mostly people say, health and safety, that's a bit dull, isn't it? So I thought I'd put one of our experiments up on the board there for you to have a look at to show that we're not boring at all. So this is a example of a van explosion. So we've had some exploding vans around the world that we've identified have been the result of an oxyacetylene leak from welding equipment. So we set up an experiment with a van, released some oxyacetylene and ignited it, and you can see the result. So just to prove that we're not dull. So what else do we do at the Health and Safety Laboratory? We do pretty much anything you like. So we're everything from explosives testing, as you've seen, to geographical information systems, microbiology, toxicology, immunology, psychology, everything. So we're a bit like Toys R Us for scientists. So I work in the microbiology lab, and we do, again, all sorts in microbiology. So one day we might be on a composting site testing aerosols for the presence of bacteria. The next we might be looking at embalming fluids and looking at their efficacy and exposure to things like formaldehyde of the embalmers. The next we might be looking at the sterility of tattoo inks, to testing personal protective equipment, like you can see the mask at the bottom there, for looking at protection against influenza. Guidance writing, training, and also disinfectant testing, so disinfectant products and disinfectant systems, and hence why I'm here to introduce this session today. So, reducing microorganisms. Microorganisms, as you know, are all around us. Most are not harmful to us. Many are very beneficial to us, and we couldn't actually survive without them. However, there are times where we need to reduce those levels to as low as we possibly can. So for example, if we were decommissioning our containment level 3 or containment level 4 facilities, then we'd want to reduce those levels hopefully down to 0. We'd use a fumigant for that. In other areas, there might be pharmaceutical clean rooms, electrical clean rooms for producing electronics, and of course in the hospital environment. Why is it important to reduce the numbers of microorganisms in the hospital environment? Well, as you know, our patients are usually immunocompromised, which means they can uptake infection more readily. The transmission from one patient to another, we need to break that chain of infection. We also want to protect our healthcare workers, which is partially my job. So we want to prevent you becoming ill in the first place and also prevent you from transmitting infection to your patients. So it's important to decontaminate. When do we do it? We do it routinely. We also do it in response to a specific contamination event. So many people get confused between these terms, cleaning and disinfection and sterilisation. And I've put this spot the difference up. I know you'll be trying to find the differences rather than listening to me, so I'm going to move on. So, cleaning, the physical act of removing microorganisms and contaminants from a surface. And the principle of that isn't necessarily to reduce the numbers of microorganisms, though that does happen in part, but it's mainly to reduce the soilants, the organic compounds that are there that may inhibit the disinfectant itself. And this step must occur before decontamination, disinfection, sterilisation. So cleaning removes microorganisms. Disinfection is the process of using heat or chemicals to reduce the numbers of microorganisms in the environment. In terms of laboratory testing, that means that generally we would like to see in excess of a 4-log reduction in the numbers of microorganisms. But it doesn't necessarily remove all microorganisms, particularly spores that are notoriously difficult to kill, like C. diff. And sterilisation then renders an object, or supposedly renders an object, free from any viable microorganisms. In terms of laboratory testing, we would expect an in excess of 6-log kill. So at the Health and Safety Laboratory, we test many systems and products. Vaporized hydrogen peroxide, formaldehyde as we use in our labs, ozone, chlorine dioxide, UV light, peracetic acid systems. We've even used electrolyzed brine, all sorts of chemicals. And each of these systems has, I don't know what that is. Can I reduce that? Each of these systems has both benefits and challenges no matter what the system. So for example, the considerations that we might want to bear in mind are: how effective is the system that we're going to be using? Does it kill the organisms that we want it to kill? Does it kill C. diff to the extent that we want? Is there a requirement for neutralisation? So for example, formaldehyde that we use commonly may require neutralisation with ammonia prior to release to the atmosphere. The types of materials in the room, so for example the soft furnishings, the mattresses on the beds that often absorb hydrogen peroxide, formaldehyde, chlorine dioxide, for example, they absorb the fumigant, but then after a time they release that fumigant back out. So when you think it's safe to re-enter a room, over time it may increase in that level again. How easy is it to use? We often look at these systems and see how easy it is to use. Is it complicated? How reliable is that system? We've had a few systems where you can use it a couple of times and then it'll break and you have to get the manufacturer out to rectify that problem. How long does it take? That's a key consideration in healthcare. You know, does it take 4 hours as a minimum, like formaldehyde? Does it take a few hours to use? And storage. So large items need good storage. We don't necessarily have access to that kind of storage, so that's another thing to bear in mind. And obviously the price of a system. But the price is kind of an investment. So if it's a good system, you're investing in patient care, essentially reducing the levels of infection in the workplace or in the hospital. So UV disinfection systems, the disadvantages, potentially shadowing. The further away you get from a system, the less effective it becomes. The advantages of a system like this is that it's a one buy, there's no service provider, so you don't need somebody to come in and actually carry out the disinfection process for you like you do with certain others. So it's a one cost. It's easy to use, it's reliable. And with that, I will hand over to Jeff, who's going to talk to you about a UV disinfection system, a multi-emitter UVC disinfection system. Okay, Jeff.
I'm actually supposed to be Julie Jolly, who I'm clearly not. Julie Jolly had a meeting at Royal Manchester that came up, so she was unable to be here with us. But what I'm going to do is walk through her slides, as she has been the first to adopt within the NHS the Surfacide multiple emitter system. So let me walk you through her slides, and maybe we can take some questions while I'm then loading the final presentation to go a little bit more into the technical and some of the design rationale. So as I mentioned, Royal Manchester Children's Hospital began about May of 2015, and they began a trial, much so to discover and measure the efficacy, were there reductions in infections, and just to really further test the usability and some of the features, advantages that Kat very eloquently just described. So here is what her goals were, really, is to reduce the number of HAI, to reduce the cost associated with HAI and the prevention of such. The service fees, the reactionary service for VHP can be very, very costly. Not only to improve patient safety, but also to improve staff and family, especially at a children's hospital. In some of the intensive care units, the parents are there much of the time. And so they found actually that the biological burden in those high intense patient areas where family were more prevalent were actually the ones that were most contaminated. To make it more effective, to improve the overall patient experience within Royal Manchester, and what I think Julie really hits on well here is where VHP is designed to be used after an outbreak or an event as a reactive kind of modality. The benefits to Surfacide and to using of UVC disinfection is to be proactive, to do it prior to and to minimize and keep the biological burden lower. So as I mentioned, they did a UVC pilot study followed by research, followed up on with an NHS certified microbiology lab. What is it and how does Surfacide work and why are they utilizing it and why have they now gone on as the press release that we were actually in Manchester for yesterday. You should see some things coming out in the media. They've just now adopted 4 systems that we've delivered in the last week, and then touch on some of the safety aspects of use of this as well. So UVC is it's an invisible spectrum within the light spectrum. It actually falls within that kind of 200 to 300 range to 280. The Surfacide system utilizes 254 nanometer UVC energy, and the reason we did so is because it's the most germicidal. The mechanism of action and really what it does is it works down to the genetic level. It so disrupts the protein bonds at a genetic level that it renders the microorganism unable and incapable of reproduction. And to the extent, it's really just time and distance. And that's what Kat mentioned earlier, the shadowed regions. Obviously, if we don't have direct line of sight to it, we can't disable it. And if we aren't in close enough proximity to have the intensity, it just increases the time demand to get that germicidal effect. For the same reason that it's harmful to and germicidal, it can also be harmful to humans. So we do so safely by using all kinds of safety precautions that are built in to the system. And I can walk you through that in the next presentation. So one of the things that is most unique about Surfacide is that we realized, and we had the benefit of seeing a lot of the first generation UV systems that were out there, and the way we compensate and overcame the shadowed regions was by developing a multiple emitter approach. So our system is designed to have 3 emitters that can then triangulate the energy and get direct line of sight access to more of those high touch surfaces. We utilize those together or in conjunction during a single automated cycle, and we utilize technology to automate it and a Bluetooth user interface between a tablet that controls and makes sure the system is done so safely and with minimal time while still ensuring that we're going to reach adequate levels for disinfection. We can also be flexible and adaptable. So Royal Manchester have multiple systems. For large rooms such as this, we can combine multiple systems and the tablet will be capable of communicating and controlling multiple. For a single bathroom, we can control as little as 1 tower. So it's flexible and adaptable according to the space requirement. The typical single patient room will typically be positioned as shown here, where one is on either side of the patient bed and then one typically near the foot of the bed. And by doing that, we can cover both the bathroom as well as the patient area. A typical single patient room is going to be about a 12 to 15 minute cycle. Larger rooms will be a little bit longer. I'll later also show you how the most frequent use at Royal Manchester is in the wards or the multi-bedded bays. Because of our design, we're able to limit the delivery of energy to the patient area and do so while the rest of the ward is occupied without delivering radiation or energy outward to the adjacent patient or to the staff that are working outside of the drawn curtains. This gives you a little bit of a glimpse into the app and the preloaded tablet. It's about as easy as making a phone call. It's like a smartphone. We designed the graphic user interface to be super intuitive. Many of the housekeeping personnel have not had a lot of IT experience, so we knew that it had to be super intuitive and very, very easy and automated. We also protect it with the safety sensors. So outside the room will be the tablet holder with a warning standard. Inside the room and any entrance or egress point, we put safety sensors. Those are both passive infrared detection or motion detection if they should be moved. And it'll instantly fail the system to safe, so there's no UVC exposure. On the tablet, the user then can, when the space is made safe, easily push resume and the cycle will continue where left off. So where they're using it, they're kind of dividing up the areas or the wings within RMCH. They're using it in the mornings during kind of their daily cleans, either in dirty utilities or in patient restrooms or even in some of the public restrooms. Weekly, they're doing parents' rooms, the kitchens, and some of the treatment areas or treatment rooms. And then monthly, they're doing storerooms and equipment rooms. They're often doing every discharge, particularly in those high-intensity care centers, the oncology ward, the transplant ward, the infectious or contact precautions areas within RMCH. And they're continuously monitoring their compliance and use. Because the tablet is capturing every single cycle, it's archived on the tablet as well as published out to the cloud. The administrators or the directors in management can monitor the utilization and correlate that to where and how often it's being used, what the average cycle times are, correlate that to reported infections or known areas, and monitor the outcome and or utilization. They've also done a fair amount of study, both within the first year of use and they're continuing to do study. I summarized their first paper. This was actually presented in America at the APIC show or convention. And really what they wanted to do is in the hematology or oncology unit, Ward 84, where they were noting some of the worst HAIs. They wanted to test it there and see if it made a difference. They also did experience that in other wards, they did result in significant reduction. In the first year in Ward 84, they documented a 43% reduction in overall HAIs. One of the things that Julie also notes and is quick to point out that the patients and their families, as well as their staff, were incredibly supportive. They just had a feeling of security and safety and very appreciative of the due diligence and the extra added care. The staff also provided them with feedback surveys on ease of use and or issues with deploying the technology, and it scored incredibly high, which then led them on to going to wide-scale implementation. The conclusion in Julie's poster presentation was the use of the system in a proactive manner alongside of current infection control guidelines can help in the reduction of HAIs, which leads to good care. One of the other things that they had to do in kind of reaching to the NHS framework as well as the administration of the trust was make a financial justification. And so in doing so, they had to look at such things as other services that were being eliminated. And they have experienced a significant reduction in the VHP service utilization because it was less episodic, so they're being proactive. That, as well as some of the offset of direct cost to HAIs, helped them to make the financial justification. So now if you bear with me just for a minute, I am going to load this. You should think it would be me that's jet lagged, but this computer seems to be a little slower than some of the videos that I have on here. So let's bear with each other and see how they do. We'll get through it. While we're waiting for that to load, I'll tell you a little bit about Surfacide. So we're obviously, I talk funny. We're from America. We're just north of Chicago in Milwaukee, Wisconsin. and we are manufacturing those there. We've been on the market for just about 3 years. So UVC has been more widely adopted in parts of the world. US, there's probably about 1,000 hospitals that are utilizing UVC on a daily basis of approximately 5,800. So it's still a newly adopting standard. We've been on the market just for about 3 years. We're utilized in 200 to 220 hospitals. We're also utilized now here in a few in the NHS, but in the Middle East. We're undergoing some evaluations in Saudi Arabia. We've been certified by the Dubai Health Authority. I'm going on to Turkey. We're working with the Ministry of Health there, and as well in Latin America, the Ministry of Health with Mexico, the Ministry of Health in Panama. We just shipped today to both Peru and Chile. So it's kind of a newly evolving and newly adopted technology. So let's walk through it, hopefully. Keep going here. So the preface to it is really, and we try to stay within the known and the literature. And the literature tell us that 50% of the high-touch surfaces, even after manual cleaning, are not adequately disinfected. And that was a really good lead-in that Kat provided about the differences between cleaning, disinfection, and sterilization. And it's not for a lack of effort. It's not for a lack of trying or doing what they want or could do best. The workflow, the time demands in high occupancy hospitals, and the prevalence of technology makes the topographies and the numbers of technology in the room, there's so many more surfaces. So the challenge is greater than it ever has been. And so the literature also shows that there is a direct link from transmission of high-touch surfaces that then the patient, their family, or the healthcare workers act as a vector for that transmission. Let me back up. Again, it's being a little bit finicky and weird, but we also have all kinds of data, and we've done literally hundreds of kill studies all over the world on measuring kind of the effectiveness. We're typically going to be in that 4 to 6 log reduction, including C. diff and C. diff spore, MRSA. We've got a very good study on the MERS virus. The vegetative are much more susceptible to UVC energy. Really all viruses are, even less so than, or more so than are the vegetative. But the kingpin that we measure a lot, we have a problem with it in America, probably more than you do, but we also measure C. diff spore because its physical composition has the greatest resistance to UV radiation. So it takes more energy to disinfect and kill C. diff spore than it does the other microorganisms. So when we've gotten to the level of a 4 or 5 log reduction in C. diff, we've disabled all of the other microorganisms. And so that's why we see a lot of UVC measured to C. diff spore. Let's walk through a little bit of some of the evidence that we have accumulated, and I'll walk you through. Well, let's talk about, first of all, what we touched on earlier. And we are also limited by these physical constraints. All systems have benefits and disadvantages. But what we try to do is utilize technology and design and protocol to overcome them better than did the first generation systems. So the first was shadows. We've talked about that. The second is distance. As an object gets further away, the energy intensity diminishes. And it's not in a linear fashion. It's actually logarithmic fashion, and I'll show you that in a minute. The third thing that is not immediately a consideration is the labor and the component and the cost for deploying the technology. It's one thing to acquire it, it's another thing to then be able to implement and use it. And so what we thought was very important was doing a single automated and making it super easy to use, push start, and then go do other things and multitask while the UV is doing its job. So some of our hospitals have either dedicated a single housekeeper that can monitor and operate multiple systems within a hospital or within an area. Others have just kept their normal workflow and added that on to housekeepers. And while they're setting it up, which takes about 2 to 3 minutes, they push start, then they go resume their other duties, and they integrate that into the workflow. But it's a big consideration, whereas single emitters require multiple repositions. So they're typically going to be 5 to 10 minute cycles, very difficult to multitask with a 5-minute cycle. And then you have to use guesswork to go in and reposition it from position A to B to C and potentially D within the same room. It also results in longer cycle times, which means that your turnover rate of bed is much, much slower. Ours is going to be about a 15-minute total cycle time. The result, though, of all UVC is to do the most amount of energy you can in a reasonable time, because that's going to get to a kill rate, and really the result is improving the safety of the environment. As I mentioned, we're in about 200-ish US installations, and we're not trying to brag. What I like to focus on here is we've learned a lot about what challenges there are in a lot of variety of hospital settings. Huge teaching institutions, operating rooms, ICUs, patient rooms, individual patient rooms, multi-bedded bays, all of the different areas. And we've made over about 180 iterations in both software and hardware to accommodate the feedback that we've gotten. We're a super collaborative company. We just like to do that. And the more we learn, the better and the more we can do with our next customer. And so the Ohio State University was kind of one of our first ones in Columbus, Ohio, but we've kind of expanded from there, and we take feedback from each and every customer to try and help us learn to do it better at the next hospital. We also make sure that we don't just market well. We like to be tried and true and proven with evidence and peer-reviewed, legitimate, controlled research. And we've got a good variety of that we can provide to you if you'd like. Some of the more recent ones, this came from a burn center in Cincinnati. It was presented at the recent American Burn Association meeting in Boston. But it was a really interesting study. They really just compared the cleaning alone, cleaning as an adjunct with Surfacide, and over a tremendous amount of cycles. You can see on the table too, 320 cultures, there were only 8 positive cultures that even showed any measurement or CFU count. And none were pathogenic, by the way, but it shows an overall kill rate. In the table 1, we can see that right what the literature was alluded to before, 47% of rooms still had positive CFU counts after manual cleaning. It's right in that ballpark of half. And there are literally dozens of studies that have shown similar to that. The positive culture growth after EVS terminal cleaning and UVC, if you look at the positive with pathogenic, was 0%. So a good study in a kind of a unique burn setting. Clasbys and Cowdies are not typically thought to be environmental infections. This comes out of Jersey Shore University Medical Center, but it's really difficult in infection control to do crossover studies because you don't want to withhold one best practice from a patient group that you know is better for them. But this ended up being kind of a pseudo crossover. They brought it into their MICU because they were experiencing above benchmark Cowdy and Clasbys. The first 4 months that they utilized it, it was dedicated to that MICU, and they had not one infection. And their infection control team was so impressed, they started utilizing it in other areas of the hospital, and guess what? Their utilization and compliance within the MICU dropped, and the infections came right back. So they got another system, and they dedicated one to the MICU and another in the other areas of the hospital, and they went 4 months without an infection again. This was presented at ID Week last fall, and there's a continuing arm of that study that will see more and more data coming out later this fall. One of our first hospitals was in upstate New York, and I should also make a little bit of an editorial commentary. A lot of times in the UVC and even all infection control technologies, you'll see these outlandish claims of how great they are, but when you read the fine print in the study, they may have changed their cleaning regimen. They may have done a new hand hygiene monitoring or some other modality, and it's really difficult to isolate to what really was the cause of that reduction. In this study, they were one of the worst performing hospitals in New York. We have in America the mandated National Health Safety Network reporting. So we're tracking all of these, as is the case here in the UK. And they had made all of those changes prior to 6 months before starting their implementation of UVC. So with Surfacide, we knew that it was controlled. There were no other changes made during that study or for 6 months prior to that. Their C. diff rates in the first year alone dropped 41%. And in year 2, they have also continued, and they are continuing to do this study. Well, our healthcare economics are a little wacky and sometimes in instances, and our costs don't directly correlate. HAI costs are actually fairly indexed stably compared to the US and the rest of the world. So their direct cost, without opportunity cost, without lost profits or all the fuzzy math coming into it, their direct cost attribution to those C. diff reductions in the first year alone was 1.4 million. So on a system that cost around roughly 125,000 US dollars, that's a pretty good investment. That recouped itself in just a matter of a few months on the direct staff, pharmacy, additional staff costs, all of those direct cost offsets. Let's walk through a little bit about the system itself, and I'll talk over the video. Those are our 3 emitters. The 2 joiners help to link it together so it can be moved as one, and then the tablet is our remote control, if you will. That touch screen controls it via Bluetooth, and it also can connect us to the cloud for reporting. The emitters are, first of all, a tall architecture. They're about 77 inches because we believe it's important to disinfect the whole room column. A lot of the first generation are shorter in stature and height, and they're driving energy down. In today's healthcare environment, there's more touch screen and things at arm's height. The laser allows us to laser map the room and measure the dimensions and automatically adjust the length of time. We position the 3 towers within there. That has an easy to maneuver ergonomic handle. And within that handle, we actually have a fluency detector that's measuring the intensity of UV. Every time that tower rotates, we're ensuring that the lamps are at full operation. Easy to maneuver, takes about 10 pounds of ergonomic force to move all 3 towers as one single unit. We have 2 motion sensors. If you should have more egress or entrance points, we'd recommend using more than that. And then the tablet holder remains outside the room, has a time countdown, so you always know at what point will that space be ready for occupation. Those then are linked together and join the system so it can be moved as a single group very easily. So we may have to, unless you have any questions about any of those, because of the way the formatting on this Windows version, it's making me go through them all again. Any questions about the physical component or the design? Yeah.
Will your slides be available?
I'm happy to make some available to you. Yes, absolutely. So I apologize about this little brief delay. So glass is impervious to UVC energy. So while there will be a bright light that could be observable by passers-by, there's absolutely no danger. The only thing that actually is pure quartz, which is the cladding of our lamps. But glass is impervious and does not allow the transmission of the radiation of UVC energy. It's also something that in some of the other systems, there's one that's pretty prevalent in the United States that is a pulse xenon system, And there is a pulsing or a strobe effect of that, which is frequently reported as an annoyance. There's also a sound associated with that every time that it kind of discharges or sets off the energy. Ours are completely silent. There is a fan, an upper and a lower fan, that monitors and keeps the lamps in their optimal operating temperature, but other than that, they're completely silent. So we talked about why we chose the germicidal range of 254. Let me touch a little bit about some of our certifications. Our lamp life is rated at continuous use 16,000. In real world, it's probably going to have a lamp life of 14,000 hours. So for the mathematicians in the audience, comes out to, depending on utilization, about 4 years of usage. So the cost is under a few £1,000s to replace all the lamps in all the emitters. So relatively low cost. That's the only consumption attributable. So Kat nailed it right on. The only cost really is that upfront cost. The operating costs are really just power, a very low amount of power, and the lamps. Our lamps do utilize mercury. However, we're below all the RoHS, the EPA, and other governmental regulations. We use about 1/3 of a standard common fluorescent lamp, and those are vaporized. Ours is a pelletized mercury amalgam that doesn't even represent enough to be mandated to dispose of in the hazardous waste stream. There's actually more risk from the glass shards should a lamp break than there is from mercury exposure. We are registered with all of the international and governmental boards and authorities. We're registered with Intertech, we're CE, we're RoHS, we're EPS, and we have registered with the European Commission for Environmental Safety as well. So this depicts the shadowing problem, and the way on the left that we can do that is shade to dark blue by having 3 emitters positioned within the room space. The only way a single emitter can do so is by repositioning. And the literature actually reports some of the single emitters. The average cycle times, even though they were running for 15 to 20 minutes, the average cycle time was 90 minutes. So can be shorter than that in full transparency, but the literature talks about as long as 90-minute cycles. And it's just a huge user of labor, and it's just very inefficient. This talks about the intensity that I mentioned earlier. So there's this inverse square law in physics, and really what that says is as the distance from an energy source doubles, you'd think that the energy would be cut in half. But it's the inverse of the square, so it's 1/4. So what that means is that it would take me 4 times longer to disinfect that gentleman than it would to Kat, because Kat's twice as close as he is. So when we have 3 emitters in a room, we can leverage that physics by diminishing the time because the intensity of that energy is greater. And that's depicted here, hopefully, in this next animation. That was a little herky-jerky earlier. But we can see as that energy gets further and further out, objects that are closer take even less time, 1/4 the time. And then as we get further and further out, it just takes us longer to get there. Another thing that our design incorporates that you'll see here momentarily, hopefully, is rather than sending energy out in every direction, we use a parabolic concentrator. And what that does is it minimizes energy loss. No energy is internalized to our emitters, and it concentrates and focalizes it, and then we pivot and rotate to deliver that intense energy in every direction for the appropriate amount of exposure given the distance from the emitter. So it automates that. We laser map every room. Oh, I pushed one too many times. Our system is so magical we can go downhill and still hold on to it, and uphill and still hold on to it. But it is designed to be moved very easily throughout a healthcare environment and space, and that has been validated at RMCH. So I mentioned we can decouple it for bathrooms. We can also add in more for bigger spaces. This is not playing as a video, but it depicts how, if this is shown obviously in an operating room theater, but if you could imagine that as being a multi-bedded bay, we can utilize the lasers to choose the margin on the right and on the left, and we choose those as our start point and our end point. And rather than disinfecting the whole room, all three towers will scrub or oscillate back and forth to those two user-defined points. And so in about a 7 to 9 minute cycle, we can focus and concentrate energy on only that user-defined area, and we can do so safely. Because as you see, the backs of the units are directed towards us. There's no radiation or environmental exposure rearward or outside the margins of those start and stop points. So it's safe for the staff, the adjacent patient, and it's very, very quick. And this is the predominance of the cycles that are being done at RMCH. Can also use that scrub cycle to disinfect equipment on wire shelf. And this just gives you a little bit of a glimpse to what is pushed out into the cloud that the administrators, users, directors, managers, supervisors can all have access to. I'm a huge pivot table and Excel freak, so we basically made all the user-defined parameters on the left, and then you can prioritize and sort by clicking above. They're also savable, so you can choose your report configuration, save it, and then choose a recipient list and a regularity to which it's automatically broadcasted. So if you want to do, you're the OR director, you could say, I want only those in the operating room in these room listed numbers, and I want every Monday morning to see all operating room cycles. You would get an automated Excel, PDF, HTML report of what had been done the previous week. We do have a simulator and a demo. It's virtually been used within all of the areas of the hospital: contact isolation rooms, patient and treatment areas, operating rooms. We have many that are doing it daily. If you'd like more information, we're happy to set up a simulated demonstration, and we can do a webinar. This is our manufacturing facility, and hopefully what I've been able to kind of walk through is how important shadows are and how we've overcome those, how the distance and the multiple emitter approach overcomes that, the validation that's required with both fluency meter as well as the laser measurement, and then the labor and efficiency component to it. But really what we're all about is better outcomes. That's why we're in healthcare. So, thank you for your time and attention.